Hi, this video is on how to factor out the greatest common factor. Factoring has never been my students' favorite topic in the past, but it doesn't have to be a difficult topic. Really, you just spent some time, probably recently, multiplying certain things out that look like this. You probably had a 4x plus 1 in here, and you distributed to both terms. So 3x squared times 4x is 12x to the third. And 3x squared times a 1 is plus 3x squared. So going from this stage right here to this stage is called multiplying. And there are some different techniques for multiplying, but essentially we had to distribute here. Notice when we multiply, you end up with a bunch of terms. Notice what we started with looked like something times something. But once we went ahead and distributed, it ended up being stuff plus stuff. Multiple terms, in this case 2 terms. So really, this is multiplying, and factoring is all about reversing that process. See, factoring and multiplying undo each other. So if somebody handed me this and asked me to factor it, by the time I'm done, I would be showing them what they had before they multiplied out, what they started with for a product. Okay, so it basically is undoing the distribution process that we used. Now, let me actually start with a fresh problem. Let's do an example. Let's take something like 3x to the 5th plus 6x squared. Let's say, see, notice how this form matches this. So somebody had something times something. They probably had something out front, and they had probably a couple of terms inside. And what we're going to try to discover is what must have been on the outside. Question: do you think a 7 could have been outside here? Do you think I could have had a 7? Well, did you notice 7 times things don't give us nice numbers, usually like 3 and 6. So I know that some number was distributed, but it came up with numbers like 3 and 6. So what you want to ask yourself is, you want to say, what is the largest number that goes evenly into 3 and evenly also into 6? And 3 goes into 3 and 3 goes into 6 evenly. So guess what? They had a 3 out in front. Also, they multiplied some x's through too, because I noticed these have x's. Both of these terms have x's in them. Well, could they have had x to the first? Sure. But did you notice that there's even more x's that I could have taken out? In fact, let's ask, could they have had x to the third? X to the third times, we can think of something that would multiply that by x squared in order to get this. But why wouldn't this second term have at least 3 factors of x, if indeed it was x to the third out here? See, x to the third times something would make that at least be an x to the third, but I only have x squared. So that's more x's than are common to both. So let's try. It's possible that there was an x squared out here. So when you know that there are x's in both terms, you can take out the amount of x's, the number of x factors that existed in the term that had the fewest. In this case, x squared. And I say that times what would give me this term? Well, the 3 times a 1 is the 3. I don't have to actually write the 1, and I probably wouldn't write it in my final answer. But x squared times something has to give me this. remembering that I'm going to add exponents if the bases are the same, I say 2 plus what would give me a 5? And then saying this times what gives me this, well, first of all, it's positive times some sign. That gives me a positive result, so it must have been positive times positive. 3 times what gives me 6. And 3 times what, 3x squared times what gives me x squared. This already has the number of x's that this term has, so we don't want any additional. If I put an x here, then I'm going to get x to the third, but I only want x squared. So no x's in that second term. So the way I would probably write my final answer is I'd write it x to the third plus 2 inside here. And the part that was common to both terms, there was a 3 out of both terms, and there were at least 2 factors of x in both terms. And this would now be considered factored. This is not factored because it's written as a sum of terms or a difference of terms. This is now written as multiplication, so we consider this factored. Factored is one of those words that has more than one meaning in the English language. But one form is to rewrite as a product. So this is now stuff times stuff. That's what a product is. You know you're done factoring when this is expressed as a product. So this would be the factored form. This is reversing the greatest common factor. So basically, with something like this, you take the greatest common factor, you put it out in front of a single set of parentheses. It could have numbers, it could have powers of x, it could have both. This one had both. Okay, and then when we distribute that, you can see that it comes out to the original problem. So this is how I would report my final answer. We're going to look at another example. Take a screenshot of this if you want it. You take a screenshot by pressing the home key and the power key on your iPads at the same time, and then it stores it in your photos. I assume almost all of you know that because I usually ask you guys for help with technology. Okay, here's example 2. If I had 2x to the 5th plus 8. Again, if this can even be factored using the greatest common factor method, then that means somebody started with something out in front and some terms that are inside here and distributed. So let's check and see what we would do. Look at the numbers. What is the biggest number that goes into 2 and 8? Well, 2 goes evenly into itself, and it also goes evenly into 8. So definitely the 2 is out front. Then the next question, are there x's in both terms? Well, there aren't. There's only in one of the terms. So there will not be any x's out here, because if there had been, when you distribute them, all of the terms would have gotten some x's. So guess what? In this case, 2 is the only common factor. There was no variable that was common to every terms. Okay, so x to the 2 times x to the 5th gives me 2x to the 5th. And then plus 2 times what gives me 8? A positive 4. And I'm done. I took this and I factored it. And this problem, unlike the first problem, only had a number that could go out in front. Another example. Again, you can screenshot this, or hopefully it worked its way into your notes. This is example 3. If I had something like 4x to the 7th minus x, I take a look at that, and if somebody says factor this, I say that's like a little puzzle. I got to figure out what they put out in front and then what terms go inside. Do you think there could have been a number out in front? Well, keep in mind that this right here is like a -1. So basically, there's no number that's been common to both terms other than 1. We don't factor out a 1 because factoring out a 1 could happen on every problem, and it doesn't really affect us here. So there's no number that's going to be out here. However, there are x's in both terms. How many x's do I take out? I look for the term with the fewest x's, and I take out just an x to the first power here. And again, I don't usually write that one, but it's probably good until you're comfortable with this to remind yourself that an x with no exponent is really x to the first. Then I work backwards. X times what would give me this? Well, I don't have any number here, so I have to multiply. The number must have been here if I wound up with a 4. X to the first times x to the 6th. You add the exponent, it comes out to be this. And this times what gives you the opposite of itself? Anything times 1 gives you itself, and you want to get a negative x, so it's going to be a -1. There you go. That ends this video on factoring out a common factor.